Hey guys, today we're going to start talking about conics, okay? Now, let me just give you the rundown for what you need to know for conics for any upcoming tests as far as in our pre-cal class. The main type of question you see from conics is definition questions. They basically just want to ask you, do you know the definition of different types of conics, okay? And we're going to talk about the 4 types of conics, okay? Now, conics are all made from the intersection of a plane with 2 double-napped cones. Let me show you a little GIF, or GIF, however you like to pronounce it, that kind of helps explain conics. So you see this double-napped cone? Alright? You see that we have a plane going through it? The way we cross a plane through a double-napped cone creates what we call conics. Okay? So, let's start. Here's our first conic. That's a circle. Our second conic, that's an ellipse. Our third conic is a parabola. And our fourth conic is called a hyperbola. Okay, hyperbola. Alright? So those are our 4 types of conics. Once again, we get a circle from intersecting the plane and the double napped cone. We get an ellipse by angling it. We get a parabola by angling it through one, intersecting one, not the other. And we get a hyperbola by it intersecting through both. Alright, so let's go back and let's take a look at some of these definitions in word format. Okay? So the first conic we're going to talk about is an ellipse. And you really do need to write these definitions down. You need to pause the video and write this definition down. It is expected that you will know it. Okay? An ellipse is the set of all points in a plane such that the sum of the distances from the 2 points, which we call foci, is a constant. Okay? So in other words, you know, if I was from foci 1 to this point, and from foci 2 to this point, if I add those together, it would be the same number as if I went from foci 1 to some point right here, and foci 2 to some point right here. The distance here and the distance here, if I was to add them together, would be the same distance as from here to here. Okay? That's what that means. But really, as far as test goes, this is what you're going to see the most. Okay? You're going to need to know that definition. Alright? Now, this is the equation of an ellipse, okay? X minus h squared divided by a squared plus y minus k squared divided by b squared is equal to 1. You might be wondering, what are a and b? A and b are our axes, okay? So, a second ago we saw an ellipse, okay? And we see an ellipse can either be longer or it can be taller, okay? So it either has a greater axis on the x or it has a greater axis on the y. Okay, if the x-axis is longer than the y-axis, we say it has a major horizontal axis. If the y-axis is longer than the x, we say it has a major vertical axis. Okay, vertical representing the y's, horizontal representing the x's. All right, so this is the standard equation for it. Okay, now you might be wondering, what are h and k? H and k is just the center, okay, of your ellipse. Okay, so if you go back here, the center for this ellipse is the point 0, 0. Alright? So HK just represents the center of the ellipse. Alright? So this is just the standard form equation for an ellipse. You do want to write that down as well. Okay? So let's go to our next conic. Right now I'm just going to give you a brief overview of what each conic is. I'm going to kind of tell you the definition, and then I'm going to show you the equation. Alright? Our next conic is going to be a hyperbola. A hyperbola is the set of points in a plane, the absolute value of the difference of whose distance from 2 fixed points called foci is a constant. Okay, so this is what a hyperbola looks like. Alright, so you really do need to memorize this definition. Alright, but basically a hyperbola, a way to kind of remember it, is the idea that it's just 2 parabolas. Okay, it's just 2 parabolas back to back. Okay, so that's kind of what a hyperbola is. Let me show you the equation for hyperbola. Alright, so these are the 2 different equations for hyperbolas. You'll notice the difference is the hyperbola is open side to side when the x goes first in all this. And the hyperbola is open up and down when the y goes first in all this. Alright, now this hyperbola is all centered at hk as well. Alright, so the definition was the set of points in a plane, the absolute value of the difference of whose distances from 2 fixed points called foci is a constant. So it just means that if I was to do f2 minus f1, it would be a constant value regardless of, like, if you went here to here and then here to here, the distance between the two, no, the absolute value of the difference between the two would be the same number the entire time. All right? The next conic we're going to talk about is a parabola. You already know a parabola, but you still need to know this definition. A parabola is a set of all points x, y in a plane that are equidistant, that means they're the same distance, from a fixed line called the directrix and a fixed point called the focus, not on the line. Okay? So what that means is that the distance from the directrix to any point on your parabola is the same distance as that point to the focus. So like D1, the distance from the directrix here to the parabola is the same distance as the parabola to the focus. So these are the same distances. Same idea here with D2. All right? And so this is the, I did not write down the equation for a parabola. We don't actually test on it at all. But if you really want to know it, it is y minus k squared is equal to 4p x minus h squared. All right? We don't really test on it. For as far as parabola goes, we really just focus on you being able to know the definition. Conics are very definition heavy. You notice I repeat that several times. Okay? Circle. Circle is a set of coplanar points equidistant from a given point. The given point is called the center of the circle. The distance from the center of the circle is called the radius. All right? You guys all know that. Okay? Here is the equation of a circle in standard form. X minus h squared plus y minus k squared is equal to r squared. R is the radius and the center is the point h comma k. Again, we're very definition heavy, so you need to know this definition. Okay. Now this is a little GIF again, just showing you how these things happen. They happen through the creation of a double napped cone. All right, that is how they happen. Okay, so you see how this goes each time. So you take a plane, you cut it through a double napped cone, just one of them, you get a circle. You tilt that plane, you get an ellipse. You tilt that plane a little bit more, you get a parabola. You tilt it even more, so now it's intersecting both, you get a hyperbola. I recommend watching that a couple times. So plane cuts through the double napped cone, you get a circle, cuts through a little bit more, you get an ellipse, cuts through a little bit more, you get a parabola, cuts through even more, so now it's cutting through both, you get a hyperbola. All right, let's do a problem. Now, I do want to reiterate, the tests are definition heavy on conics. I'm not going to quiz you on definition questions during this video. You will see it on the quiz in a second, though. All right? But in this video, I'm not going to go back to the definitions, but I recommend you do. All right? So it says, determine the equation of the ellipse centered at -1, 5 with a horizontal major axis of length 10 and a vertical minor axis of length 6. Okay, so first off, let's write down what we know the standard equation to be. X minus h squared divided by a squared plus y minus k squared, oh, that should be a parentheses, divided by b squared is equal to 1. All right. H and k is just simply your center, okay? So I know my center is -1, 5. So if I plug in this -1 for h, what am I going to get? X plus 1. So I get x plus 1 squared, and we'll take care of the a part in just a second. I'm going to explain that part in just a second. All right, and then the k value is just 5, so you're just going to plug that in. So you're going to get y minus 5 squared over, and we're going to talk about that in just a second as well. All right, so now we're talking about a and b. Okay. Remember when we talked about an ellipse a while back, and we talked about how an ellipse can either be taller or it can be longer? Okay? If the ellipse is taller, that means it has a major vertical axis and a minor horizontal axis. If an ellipse is longer, that means it has a major horizontal axis and a minor vertical axis. Okay? So in this case, when we think about it, it says we have a horizontal major axis. So that means our x is longer than our y. So it says our x is length 10. So first off, this 10 is going to be involved with this x. Okay? So we're going to say that its a value, because that's what a represents an axis. A and b are just your axis lengths. Okay? A and b are just your axis lengths. A and B are just your axis lengths. So, if A is 10, then A squared is going to be 100. That's a 100, not a 106. 100. And it says vertical minor axis of length 6. That means that my y-axis is 6. So that's B. So that is B. So that means B squared is going to be 36. And there I go. I have my equation, not two equation. I have my ellipse equation. Okay? Let's do another one like that. Okay, let's do another question like that. Determine the equation of an ellipse centered at 3, 9 with a minor horizontal axis of 16 and a major vertical axis of 49. Alright? So, let's remember the ellipse equation. X minus h squared divided by a squared plus y minus k squared over b squared is equal to 1. Okay, now h and k just represent my center. My center is 3, 9. So if I plug those in, I would get x minus 3 squared, and we'll take care of that a in just a second, plus y minus 9 squared. Okay, so now let's get this a and this b. Okay, so we need to find the horizontal axis here. It says minor horizontal axis is 16. Okay, so I picked ridiculously large numbers because I wasn't thinking straight. But 16 is A. Alright, so that's our A value. So then A squared is just going to be 16 squared, which is 256. And then it says major vertical axis. And you know that vertical goes with y. So that means that we need to do 49 squared. So 49 squared is 2401. And this all equals 1. Alright, so that's how you make an equation from ellipse. So today, the video, all I want you to get from this video is those 4 definitions of an ellipse, a hyperbola, a parabola, and a circle. I need you to know those 4 definitions. Okay? Then I also just want you to be able to write an equation of an ellipse given that information. I'm not looking for you to get more than that today. Alright, we'll do more when we get back from Christmas break. But today, I just want you to be able to do those things. Okay? So, let me know if you have any questions. Have a great evening. Hey, if I'm doing this right, this is appearing at the very end where I just said, let me know if you have any questions. Have a good night. So, there was something I noticed I did not mention in my video. So I showed y'all this little animated GIF, of there's a circle, there's a parabola, there's a parabola, the other one was ellipse, sorry, and there's a hyperbola. And I talked about them, but I didn't give you a definition in words. So I want you guys to also have a definition in words because we do see that come up on the test. Okay? So a hyperbola is the intersection of a double-napped cone and a vertical plane which does not intersect the vertex of a cone. Alright, so if you go back to that GIF and you think about this GIF, okay, so let's wait till we're at I'm doing this backwards, but let's wait till we're at a hyperbola. And bam, we have the horizontal plane intersecting a double-napped cone, does not intersect the vertex, but it's at a diagonal, so we see that that is a parabola. Okay? The intersection of a double-napped cone and a horizontal plane, which is diagonal to the base of the cone, and does not intersect the vertex of the cone, is an ellipse. Okay? The intersection of a double-napped cone and horizontal plane, which is parallel to the base of the cone, does not intersect the vertex of the cone, is a circle. Alright, so think about that GIF while you're reading each one of these. You know what I'm going to do? Hold on. I'm going to bring that over here real fast so we can even have these two together. Alright, so think about this GIF as we're reading through these. Okay, so let's start here. We're going to do hyperbola again. Hold on. We're going to let it repeat itself, and then we're going to do hyperbola. So let's read through. Hyperbola is also the intersection of a double-napped cone and a vertical plane, which does not intersect the vertex of the cone. So here we have our 2 double-napped cones. We see our plane is becoming much more vertical. Now it's vertical. It does not intersect the vertex. And we saw that it created 2 parabolas. So that's a hyperbola. An ellipse is the intersection of double nut cone and horizontal plane, which is diagonal to the base. We're diagonal to the base, so we create an ellipse. Okay. The intersection of double nut cone and a horizontal plane, which is parallel to the base of the cone and does not intersect the vertex of the cone, is a circle. So we're going to see that happen here. It intersects one cone, it is a circle. The intersection of the double nut cone and a horizontal plane, which is diagonal to the base of the cone, only intersects one of the cones, is a parabola. Alright, so we're going to see that come around. So first, we see our horizontal plane become completely horizontal, but not intersecting the vertex. That's a circle. Now it's at diagonal to the base, so it's an ellipse. Now we're only intersecting one, so it's a parabola. Alright, so that is important information. Seriously, guys, pause this video, write these 4 things down. You do see them come up on a test. Alright?